been away from the stream for a bit. But we're back, and let's just see. We have some issues here with the way our chat is being displayed. Anyway, aside from that, we are good to go. So I did a lot of refactoring last time. I don't like to use the word refactoring. We restructured some of the infrastructure code. We didn't really change the business logic that our solution has. I did update Cursor AI, and unfortunately did this funky thing with Draw.io, where it used these really ugly colors, but it's darker. So those of you looking at this at night are going to be happy. It's not fewer things that are. I mean, the errors stand out. This is one thing that's kind of ugly. Not sure why Draw.io decided to reset the colors like this, but here we are. We'll take this as a thing to fix another time. So again, this is our application that has these UIs, obviously now in dark colors by default. So the workflows that we have are named up here, and of course these also are hard to read now. So maybe we should change those so that they're more legible here. Can't really read any of those things. So yeah, I'm not sure if it's the add-in or Draw.io that changed, but definitely this happened when we had an update to Cursor AI. So perhaps that reset the Draw.io plugin. So let's see, the font color is white. Odd. Anyway, we'll fix this up. I think there's a view here for how this is displayed. Let's see, extras, diagram language, view, shapes. No. But if it had a menu item here, if I had to go into if I had to go into the settings. But anyway, here so yeah, if you've used Draw.io and ran into the same problem, let me know. Somewhere in here is adaptive colors. Oh, there we go. Simple colors. That's what it was. Okay, so it reset that setting, unfortunately. So, all right. Disaster averted. Now we can actually see what's going on. Okay, so now that Cursor AI is updated and we have all of this done, as I said, we had like a in between sprints effort. Let me just double check that we're live. Oh yeah, it looks like we're good. So yeah, this is again, just for those that are new to the channel here, this is an application that we're building as an example of event modeling, which is this type of design, system design, and event sourcing as the implementation, which is a way of managing system state through additive only changes, meaning these yellow stickies are events that get put on disk, and we see them stored along the way. And as we run the application, you know, we can see how it progresses. So let's just quickly take a look at how that works. Terminal here. I'm gonna split this. How do I split the terminal? Split terminal. Okay. So all the way up here. So if I do just remove everything in the event stream, and now we can do our EV events. That's our events watch. So we can start to watch what events get stored, which again is this set of events that gets stored here. As we go through each piece of the workflow, we store little bits of log, a little bit of state, meaning like what happened. We just keep adding those. These things below here are testing scenarios, kind of specifying the details of how one of these pieces is actually going to behave in different situations. So that's our full spec essentially of this piece. And so let's walk through that. Obviously, as we can see when we start the application, we're going to get URLs for all these pages, and we can start here from left to right. And I've also organized the code to be top to bottom as we go from left to right on the diagram. Here we have some fake scenarios, those testing pieces. We have these testing specifications here are kind of a variation of that timeline that's in here is kind of shown in code, and we can copy these scenarios, kind of like a quick database restore for a certain situation if we want to test one of these things. The idea is that each of these can be implemented in isolation from everything else because it's very easy to set up the environment for a particular place in a workflow, which is one of the advantages of this type of development approach. So again, today's going to be a short stream. I have appointments today, but I hopefully will be back to continue to work on to the rest of the pieces. The green ones are the ones that I've done, and some of these other ones here actually should be including the previous ones because it's done, and so on. So we kind of got to the part where we're designing this voting for topics. And then we just have the schedule creation. Once people have voted for the topics, the organizers can then move all of the different sessions for the conference into the matrix for what's going to be talked about in what room at the conference and at what time. So that's kind of all that's really left in terms of the core functionality here. And so let's just see how this runs. So we're watching the events get created here. Actually, we're on this one here right now. It's yellow, meaning that's the one we're working on. So if we go back to the beginning here, and now we run our application. So let's just use the latest node and go ahead and run the tests. First of all, yeah, we have all the tests. So these scenarios here are actual tests, and I'll show you how we made them very generic. So unit testing is entirely changed in this. It's a highly opinionated way of unit testing, which I think is incredibly good because it removes the absurd nature of testing that we accept in the industry to have every test being done differently by every developer of different skill level. Here we kind of found a really good standard approach to unit testing, which really gives you the cadence that you need to be predictable in how you write your project. So let's go ahead and run that. So the tests pass, and then we'll go to just running the app itself. It'll obviously, I've instrumented that we iterate through the routes that are added. This is using Node Express. We're using an old framework just because there's a lot of code out there. We actually don't want to introduce any complexities for single page apps to demonstrate these concepts. So all the routes are quite easily visible here. I press Control and Start. It says, hey, look at that. Open. So again, and these are in the order in which we added them. So the code that I wrote is always in the order that the diagram we're looking at here is in from left to right. So let's go back here and just go back to, we're right here on the naming of the conference. So we have this kind of wizard workflow that we're following through to kind of set up the conference, and then we pass over the control to the participants. They can scan a QR code and suggest their topic. So let's keep going with the example of how this works. So if we go ahead and and name our conference. So let's just call it Event Modeling Conference. We can see if we hit the continue button, we get to the next page. We have some debug stuff that I added, kind of showing what's going on in terms of this extra view. So it gives us a count of the events that we stored so far and kind of like what the state is. There may be some more standardization that we can add to this later, but for now this is good. And this watch window here just shows us, this is our database view, and our database is simply just files getting added. And so I do strip out the meta property, which just has the embedded type. I do have the type embedded in the file name. I extract that from the file name. I also have the sequence number, which is kind of like your growing ID in a regular table. We just have one for everything that happened, which is easy to understand, the global sequence. And so as we move through the workflow, we can see that we added that. So let's continue. So congratulations, your name, you've set the name of your event. Yeah, we're obviously overcomplicating this, but I did this again to just make simple examples of how you do the posts and gets and how you handle everything within event sourcing to show the current state and how you change state. So by kind of making more moving pieces that are simple, it's easier to show the concept. So continue to the dates part. Okay, now we can set up the dates. So let's do 2 days, the 14th to the 15th, and we set the dates. And notice that we have the set dates done here. We have some debug information that is coming out here. I may actually just have a debug flag in here. I added another flag to running the application. I'm going to add another, well, I shouldn't say flag, it's an option to turn certain debugging off and some ID generation to be different. You'll notice soon when we get into the different IDs that we generate that there's a length difference. Let's keep going. So we set the dates for our conference. So congratulations, you just set the dates for your event. Let's continue. Let's add some rooms to this conference. I'm just going to take these defaults that I used before and add them. Notice that they are being added, room name. That's all we really need. Now, this shows the simplicity of event sourcing, that you can start very, very quickly with very minimal implementation. All you're doing is just putting this on disk, and then anything that you want to show is just a map reduce, which is a reduce in JavaScript. In Node, you can find the equivalent in your language most likely these days, but if you don't have a reducer, you can do a for loop and just accumulate the worldview as you go through each event on disk. Again, these are just JSON objects serialized to files. That's a summary of their contents. And so let's add another one here, just to have 2 rooms. So add that. Notice that another one here. Notice that this state, this is the green thing that we show here, or that we're seeing this collection. I know it's a little too small. I can probably zoom in here. But yeah, as we add to the rooms here, we see this is actually no longer true. So we we add rooms through this interface, and it just keeps going to the same page. There's another example of this where we go between 2 separate pages. Say that there's a confirmation, you have to continue to go add another one. We'll see how that works, but you can do it either with 1 page to show both the current collection and adding them bit by bit. So now we continue on to the next step. Zoomed out. Step here. So now we're going to the registration portal, I believe. I'll tab to that. So continue. Oh, we need the time slots. Sorry, the time slots are the next ones. This is, I could definitely use some server-side JavaScript here to just make this a little bit easier. I was thinking making some presets. We have the standard 55-minute presentation, 5 minutes between presentations. So, instead of having to pick, the start times, kind of tedious. I mean, it's not too bad, but, it would be nice if this next one autofilled to 9:55 for me automatically instead of having to do it manually. So add that. that's another one here. So we can see that the time slot added is added here. This is how simple event sourcing is. There's no tables, no foreign keys to manage. You literally do all that in code quite easily with highly repeatable patterns that are simple. Yeah, so this is I wouldn't develop any other way. This is incredibly transparent as to what's going on. Oops, we fortunately didn't add that, so let's just add that. There we go. Now we can see that this other file is added, so we have 2 sessions, 2 slots for sessions. So obviously with just the 2 rooms and the 2 time slots, we have a very small conference of 4 talks happening, but that's okay for our current example. So let's continue to the next one. Now I can create the conference URL, and I kind of embellished this simple requirement. I kind of said to myself, well, what if we're actually getting the ID of the conference from an external service, or there's some crazy calculation we have to do. I wanted to show the mechanics of automation, something that's done automatically for the system. We show that with a set of gears on an event model to say that, in order to get this QR code and this screen here that people are going to be able to, the participants are going to be able to scan and start to register for the event. We're in a trusted environment here. This is not on the internet. This is usually when you get together in person at a conference, at one of these conferences. So it's a high trust environment. That's why we didn't spend a lot of time on security here. Mostly about showing the concepts of event sourcing, not all of the other things that you would put in here. We eventually will add them to here, which also will show how event sourcing makes it easy to add any number of features, be it business facing or orthogonal, value or service level or whatever. We're going to show all those concepts in these streams that I'm doing. So we're at this little gear icon here. We're about to create, we're about to press this button here, and we're going to end up with that. Again, this is showing another concept in event modeling called a to-do list. So we all our automation is done through the same pattern. There's a list of tasks that have to be done. Processors filter on those types and those specific to-do lists and pick up the jobs. When the jobs are done, those events then cross off those to-do list items. So if we go ahead and create this, notice that we had quite a bit here. I have some more debug statements in the processors, how they work. I have implementation for synchronous and asynchronous way of doing this. It's a node application, so I have a timer in the back if we have an async. So you can play around with this and switch the type of processor instrumentation to be asynchronous if you want to see the timer going. But this also shows that message-based or event-based systems don't have to be async. We simply chain the calls here directly. And we don't need to wait around for some other thread to pick things up. I use the word thread loosely here because this is a node application. Anyway, so you can see there's 2 events there. That there's a conference requested, which is a marker event. This is one of those events that has no data, which is valid. It's just the type that event type existing in the history is enough to populate something, such as over here we can see that the state, let's see, our time state change. Right. So here's the state of the processor looking, changing this conference ID to generate it here. I'm not sure actually if we have. Yeah, I don't think I'm using. Yeah, I'm not using the same HTTP request, obviously, because this is the back end, so there's no HTTP handler that deals with this. So that's why we don't have, this default state here. So we have events counts. We have the event count for state changes, results. So this debug information kind of tells you a lot. You can see here that the meta stuff that we're stripping out of the events, there's also a summary that gets put in place. This summary is actually used to be kind of like a part of the file name for the serialized events. So I don't have to open up these JSON objects to kind of get a gist of what's inside. So I embed them into the file name. But when I see our event stream on disk, it's really easy to see what actually happened here. We don't use this for business logic. This is just a helper for me if I'm looking at the events themselves on disk to see what happened. And you'll notice the real contents, they're actually here. However, I do strip the summary information, which is the part that gets put in. That is just passed along in the event in the meta part of the meta property to help with this instrumentation. But we strip it out both for testing. We have unit tests that I'll show you, and also for the actual what actually gets written onto disk. So if I look at this particular one here, where we added this room name, we have a summary that is embedded in the file name called CS400. So if we look at that, you can easily find the room added CS400. If I open this up, notice that I stripped the summary. So just before it gets written to disk, I have a strip summary method here that gets rid of that and just deletes that that property here. So let's close that and go back. So we're kind of at this point where we showed this, and again, I'm using not the full UUIDs now. I'm using just the first 8 characters because I find that when you're showing concepts on a demo, it's really hard to look at the full UUID string, which just takes up a lot of the length, and especially if you're looking at at these IDs here, that would kind of take up way more space than needed, and kind of clobber a lot of the real estate here to know what's going on. So I like to have more in terms of the context of what I'm seeing here. So far, I see that in order to get to this part of the workflow in terms of this wizard to set up the conference, including generating this conference ID, which participants will kind of use to register. Without this ID, they can't register. That's part of our business logic, so that people external to the event can't grief the event by denial of service or putting garbage in there. So that's just for the participants inside. It's kind of like a secret that it gets displayed on a projector physically just at this event. I mean, again, this is a fully trusted event, so we're not going to bother with those security things in this case for now. So this is our URL. Obviously, it's not going to help you. It's a local host running here. We're not running live anywhere. And that's another thing that this can be. It's highly portable since it's just using files. So let's go ahead and add this participant here. So this is what the registration looks like. So we're kind of onto the next part. That's as if someone just scanned that QR code. They're getting this welcome screen. I can put this up here just so that we see. Unfortunately, we're not going to see our little diagram unless I click to it. But so this is, let's just say Adam registers here. I register and it says, thank you for registering. Notice that the registered event is in here. It gives us our registration ID and it says what conference ID it is. That's another detail. We don't actually need the conference ID. This system on purpose only has one conference running at a time. The idea of multi-tenancy would not be addressed here. We're saying that one client of this system would be really running one conference at a time. This is not, this is kind of meant to be run by the organizers themselves, the whole program. Obviously, you would start to add more IDs to differentiate from different tenants, and especially if you're in a B2B reseller, you might have 2 or 3 different events being used to correlate all the events that belong together for one particular conference. But in this case, we could even get rid of this conference ID here, because the minute we generate a conference, this is the conference that's currently being done. Until we close registration, there's a few of these marker events that kind of give us an envelope, a bookend to the whole conference, like when it starts, when it finishes. And we'll see in the code that we have in our reducers, when we bump into these events of a specific type, we reset our accumulators to start from the default values, because we know we're in a new conference. And this is also a good exercise for how we treat closing the books and event sourcing, meaning we don't want giant streams that last forever. I mean, if we keep using this for years and years, we're going to have hundreds, thousands, millions of events. We don't want to be replaying all those just to run the system. So there's these natural seams in the timelines where we can cut things off and just look back at a reasonable amount of events. And not only that, but we can also have memoization and other things that require very small amount of I/O. That is no different than a typical CRUD application with databases, but we keep the integrity of the data instead of trying to guess how we got to a certain state. Here, obviously, we know exactly what happened to get to a certain state. That's why debugging these types of applications is a joy. You always have a reason why things happened. So yeah, it's a highly maintainable way to write applications. So I'll just take the role now of the participant. So as a participant, I registered. Notice that I have a registration ID in here. This is our token. I, on purpose, put it into the URL. You would never put your tokens into your URL. Obviously, someone can copy that and impersonate you. But for the purposes of a demo application, this is what this is kind of what we want people to see, that you know, this is how we do that. Obviously, we can change the implementation to take that out and keep it either in cookies or some other place, you know, in a hidden field at least, so people aren't able to look behind your shoulder, especially now that we've used 8 characters for the UUIDs. It's very easy to copy that. So let's continue on as a participant. Over here, we have no current sessions. So we're going to suggest another session. So no sessions proposed yet. We're using mustache templates in Express, which are kind of nice. I really like that simple templating syntax for the views. And it provides a default HTML if there's nothing in the collection to have this nice display. But let's just suggest another. And so we're going to do a presentation, and it's going to be on event modeling basics. Okay, so submit the topic. Now we see that we have this. It grabbed my name, so there's a lookup that we have. We'll show you how the green boxes that I showed in the event model do that. So there's our presentation here, and why not suggest another? Sure, we can suggest another presentation. I would like to present on sourcing basics. Remember, we wrote all of this from scratch. There was no boilerplate. This is the only thing that I've included is Express. UUID generation, I like the library for generating UUIDs and some other very basic libraries. But other than that, there is no database. There's nothing. This is as bare bones as we can get, which is nice that we can build all this functionality from nothing. Now, notice these events just get stored here, and we're kind of along the way to this participant section, where here we can show the topics entry screen. We kind of have a different layout, but this is just a mock-up. So we can show how, you know, we add these things, these topic suggestions, and yeah, and we also have, so one of the things that's interesting is that you can register until registration's closed. So let's add another registrant here. So we can add another thing here and copy this, another tab for another participant in the conference, another attendee. So they get the same idea here. So you have Bob, you can register. Awesome, Bob can register. So we have another registration here. We can also close registration. So this is a screen for the organizer. They have this button, and obviously we need to lock this down if people know what this URL is, we really need to have the conference ID in there so that we don't, the conference ID is never displayed to, actually it is when you're first registering. So it has to be a secret token that we have to be able to close the registration just by the organizers. We probably will add that as a feature in an upcoming version of this. But right now I can close the registration. It shows, again, without the registration, notice that the buttons for suggesting topics, the organizers are not able to show this. So that's another thing that we need to kind of evolve in the system. There's some basic patterns for being able to display some data and not display some data, display some capabilities like buttons and not show them. I think there's a very simple set of patterns that can kind of work for all of that is in line with how event sourcing works. So we'll do that. But now let's just test that out. We should be getting a rejection for trying to register when the registration is closed. No, it's still doing that, so we haven't implemented that yet. So actually, I think it shows this, but I think it throws an error. So if we do something like Charlie, if Charlie tries to register, I should have a registration is closed here, honestly, but it just gives them that. So we do have that. I mean, it would be nice to to not set people up for this disappointment and just show them that the registration's closed. So, you know, version 1.1 of this thing, or 0.8 or whatever we want to call it, 0.91, we'll have to show that ahead of time. But it's not letting people register once it's closed, and the organizers are kind of able to see this themselves too. So we have Bob and we have ourselves here. So let's see if Bob can also suggest another topic. So it's going to do a Q&A session and wants to know about scaling event-sourced systems. Okay, so they're submitting the topic. They have this, obviously, notice the registration closed event. I don't need to have the conference ID. That's what I was talking about, that we only need the ID once here for reporting purposes. And even at that point, do we really need it? I don't think we do. So for our minimal implementation of this, we probably wouldn't. We can see that all events between conference ID being generated and the registration being closed, we kind of have the beginning and the end, so we can ignore everything outside of these events. You know, if there was any registrations or topics submitted, we can ignore them if they came before this. That makes a really, really simple implementation. It's one of the beautiful things about event sourcing is how quickly you have the proper scope for these things. So now that Bob has added this, if I refresh, if the organizer refreshes their page, they can see that Bob also added something. And of course, I can also see that if I refresh my page. There we go. So both of those things are done. And I think that's kind of where we got to. We're now going to the voting page, which is not found. So our URL is not found. We haven't implemented that. That's that next yellow thing here. I did add some, so Express has this way of pipelining requests, so you can do kind of like handle your HTTP request and pass it on to another handler if you don't find a route or whatever. So we're only using the very basics of that, but I didn't want the generic white screen of death for for your errors, so I added in some custom pages for errors, so that we just have this nice black background. It's not going to be too jarring when you're watching this at night, when you're watching these streams at night. So let's just go through the code to see how we got through just setting this this basic beginning part of the organization of the conference. Notice, first of all, that we have 13 events in all in terms of all that we did. So here's our state, and this is not just logging. This is literally the files we look at to understand what we're going to show on the screen. We are not using any tables in any Postgres stuff. Everything is MapReduce. Everything is MapReduce in the application. So everything is mathematically correct at all times. And it's amazing the simplicity that that buys us. So let's explore that right now. I'm going to just get rid of this for now, this view. The application's running, so we can experiment some more with this. Again, we went all the way through all of these screens here, and now we're on this part that's not coming up right now, which is kind of, how are we going to vote on things? So putting together a simple UI that's kind of going to look like this, where we can, that list of topics that we have, we can vote for our own, maybe not, I mean, depending on what functionality we want, but we'll be able to vote for them. And then, of course, the participants are going to, the organizers are going to be able to drag and drop these things or not. I think there's a with and without JavaScript functionality here. I kind of want to show that we can have a full functionality without client-side JavaScript, just with posts and gets from forms to get all this working. But if we have JavaScript enabled, we can do these drag and drop things here, right? So all our suggested topics, probably we want to add that with like the number of votes and kind of order them in that in this sequence, so the organizers can see the most popular things at the top, and they can allocate them to different slots here by dragging and dropping. But if they don't have JavaScript enabled, we should be able to use radio buttons to say, place on schedule. Okay, I'm going to place this one into this slot by checking these. And then I think the default behavior once we place this on the schedule here is that we think of like, well, what is the next available slot and what is the next talk, and have the radio buttons to default to those, so that you can just click place on schedule one after the other and kind of like get everything populated very quickly. So I think that that'll be a nice set of features to implement on the next stream. And I have about 15 minutes to kind of show you the code, and then we can use that code to continue to build this out. So this is the part that hasn't been built. Obviously, we only show things that are built with these green rectangles, which we already demonstrated. And then something that's in progress, we have yellow. Let's put Adam in progress that I'm working on it. If you're working on a team, that's what you would kind of do. Way more fun than Jira to track all this, isn't it? Very graphical, and you know exactly what's going on. You know what you're what you're placing on the timeline at each point, and you know what you're displaying. I don't know why these became, something with this update to cursor has really screwed up Draw.io, but that's okay. At another time, it's kind of not legible here. So let's take a look at what we cleaned up in the code. For those of you that have seen this before, you'll notice there'll be a few changes here. So let's walk through the code. So of course we have the port here that we default to is 3002. Just to be different, I think it's 3001 for Node applications by default, but 3000 or something like that. I usually have some other Node thing running for some reason, and I just got sick of bumping into that port not being available, so I just changed it to 302. Slices tests, these are the tests that we run. So let me just run the tests for you here. We can peel off one more split here. Do another split terminal. Okay, so we have another terminal split. We're done looking at the files. You know how these get stored. So we can, and again, most of the logic is in just the app.js. I put everything in there, so we don't have to fly around through a lot of different files to show you everything. The only other major thing that we have here that's a separate file are the HTML templates for those pages. So we can look at those quickly if you like. And again, join on Discord. There's a live stream channel there if you have a question. Of course, if you don't catch this stream live, you can leave a question for me on Discord and see it there. I'll see it there and answer it for you, maybe on the next stream or just directly in that chat. So course, for a new terminal, we use this. This is our application running, but we can also do a node app.js test, which will give us the unit tests running. And we have a custom unit test function that we made ourselves. We don't need a unit test framework. This literally is better off running like making your own unit tests, because there's a very opinionated way that you make the unit test scenarios. It definitely isn't standard unit testing. We do want to compare the expected results as events and compare them property by property. So we don't have this opinion of, oh, that we should only have one assert per test. We do, but that assert is quite heavy. It is literally comparing the resulting JSON object with the expected JSON object, and that's the only assert that we do. Same with the state. So both changing the state and viewing the state are treated with the same thing. But we'll get to that. I put the testing framework at the bottom of the file. So that's down here. We basically iterate through those scenarios that I showed you on the diagram, but we'll get to that later. Let's just keep walking through the code. We have the sync time being the marker of whether we go async or not async. If it's 0, it means we want sync. So we're going to have a call to whatever processor we want right after we update a to-do list in the same thread. If we have this set to a value, we will then instantiate a timer that will kick off every this many milliseconds, and that'll pick up the to-do list. So it'll work asynchronously while we keep going with the application, go to other pages, etc. These we can have running whenever we want. We simply use the current directory and create a directory called event stream inside inside the working folder. So everything that's happening there happens so anything that we do in the application ends up being stored as a JSON object in there, and the whole application works by just looking at the JSON events in here, and that's all that happens. Sequencing is a padded padded 4 zeros. That's what you saw, the 0001 for the second event. This quadruple 0 is the first event that gets written, and of course we saw those here at the beginning, and that is the beginning file name as well. Then if we want to run the tests, that's the ID that I passed here when I was running these tests. So if I go here, so if I do this, it actually does not run the application. It skips running the application and just executes the tests. Here, if we want to use regular long IDs, so we want to run in production and there's going to be a lot of people, we don't want just the first 8 characters of a UID. And of course, this is where we have the requirements. I try to put everything in one line so that we don't use up a lot of real estate here. And I'm going to make this, since we're looking at code, I'm going to make this a little bit bigger just so we can read it a little bit more. We know what this stuff is, right? So let's see. I don't see the last output here. Kind of gross to look at when it's a little bit too small. Now I have to scroll, but hopefully this is helping you read on a phone when you're looking at this later. So yeah, the using shorter IDs. The reason I want to use shorter IDs, again, so we don't run out of space when we're looking at them here. They're not going to take up a lot of real estate, but we can specify long IDs if we actually want to run this in production. Our standard requires we're using Express as their framework, using the file system as our database. This is for our multiple forms that we can use on posts or multiple fields or whatever it is. Anyway, this multer is an easy way to get the form fields from a post in HTTP. In Express, we're using the mustache view engine, and then mustache express is the requirement by Node Express to use that type of templating. I haven't showed you any of the templates for the web pages. They're not that important for now. We do have some things like I guess we used to have some static pages and icons and all that. We put them in this public folder, although I'm not using any. We also use the JSON format for passing. I guess the posted data is in the form of JSON when we use this. We have error CSS, which we include. Oh yeah, the CSS is in this static thing. I'm not sure if I really need to use this. I could cut this out because I think the style. We could use the regular CSS for that. So I don't know if this is absolutely necessary. Probably ask AI to get rid of it, or if we can. So one of the things I mentioned earlier is that the meta stuff actually goes away. So in here we can see when the debug actually gives us the true events that we get out of our event command handlers. They do have the summary information in the meta tag right here. But we do strip that out of the now this watch command that's something that I created in Fish as well. So this watch command is a custom part of the custom utility that I have here. It strips the meta tag right out because the event type we get from the actual file name and the sequence number we also get from that. That's something that is not part of the core functionality. It's nothing that our reducers will be looking at for business logic. So I really want to be able to see what the core business event is on disk, and that's what we're doing here when we're looking at these things. So this essentially just deletes that summary. And of course, when we push the event, so here's simple, our event sourcing is down to these two functions. All we need to do is get the events from disk, which is simply deserializing these with JSON parse right here. That's it. We sort them based on that ID that we put at the beginning. When we want to store events, we have this push event function. All it does is it increments the the sequence. Essentially, the sequence number is the count. I should be looking at the last number, but I assume that the count of events is what we have. We can, of course, make this more robust when we do this again in terms of creating some number that is a file. So the sequence, this sequence padding, I actually should have this down here. It's related functionality to the core events, and same with this. All of this should actually be down here instead, because this is where those things get used. I try to have related stuff together in this one giant file. So I got 8 minutes left. Let's see how far we can get through this. Yeah, so this is kind of like all that it does is it gets that number, and it gets the count of events to see what that number is. And then, of course, it writes the file here to the event store, the sequence number, the event type in the file name, and the summary in the file name, and ends it with -event.json, stringifies everything here in JSON and writes it down. And then, of course, if we have the sync time equals 0, which means we are synchronous, we're not using async, then we notify the processors right away, right? And that way we have all our to-do lists processed in the same thread. If, however, we do have a sync time that's greater than 0, then we do the set notify set interval here, and our function is the notify processors. And so notify processors, that's what we do, and this is so we pass on the latest event, which is nice. Um, and this is this is how we know that we've done this asynchronously. Um, and so if we've done them, if we call them by the timer, will call them with no event. So that's how we know. And then otherwise we basically look up which processor. We don't want to call if we know what event got written. We have a lookup which shows which processors care about the event type that we just published. This can be expanded to be dynamic consistency boundary type of processing later, where we don't have to go by type. We can go to a deeper level where we can say that if anything significant happened within an event or is of something, we could go crazy with this. But right now, the default kind of behavior is just if a particular processor cares about a particular event, we're going to kick that off. And in fact, we're going to kick off each processor that cares about this type of to-do list that cares about this event. And we have a lookup for that we simply use. The other thing that we did here are these wrappers. So the reason I have this HTTP wrapper is I didn't want this code repeated in each router. Basically, if we have a failure on getting the events, we need a 500 error. I wanted to also be able to pass this off to our custom error pages. So I wouldn't want to write this code over and over again for each route. When we want to change, when we submitted something, wanted to store one of these events, this is kind of what we have for a command handler, the command. If we go on error, if we get an error in here, this is the next function that what's it called, node express gives us. So we have to have that injected into this function so we know what to call. And so the call is done here. Every time we have an error, we pass that on. However, if we're successful, we call the success action, and just in case we want to use this as a result by calling this, we return it anyway. But generally, the success action or the error next is all we need as either success or failure of anything happening here. Again, 500s are for internal things like not being able to access the file system for some reason, and things like that. Same thing with the get state. We want to show some errors, etc. And again, we have, instead of a command handler, we have a state view function. So this is basically saying, hey, we want to do this action, use this business logic. Here's the command that we want to pass to it. And you'll notice that that this result here will be done here. So this is where we call the command handler with the events and the commands. That's a standard signature for event sourcing state change. And then of course, same thing for state view, standard signature is just getting the previous history. And we can add all sorts of optimization at this level here. The important part is that we removed any HTTP repetitive code for getting error codes into this. And again, we just return state or have the action success process the next thing. Again, the access token, that registration ID in the URL, we're going to have that call all over the place. So we have the same type of issue that this code will run over and over again. We really wanted it to be wrapped up in one function where we have, this is our only security, quote unquote, that we have, is making sure that we have a registration ID present to know who we're talking about in terms of who the user is that's suggesting something. And that's that. And so now that we've gotten all that out of the way, that's kind of all that I've added since the last stream. And this makes our actual routes quite easy, because when we get, for example, setting conference name, that's our initial form that we get, we simply render that with nothing here. We could put another default message here if we wanted, but really that's all we're doing. So then when we actually post this, this upload none, that is, don't worry about this. It's just a Node Express multi-field or multi-form support for being able to take requests from the browser. So it's all over the place. There's no interaction with this at all, except when we actually have a, here, the request body conference name here. That's because of this. So we wouldn't be able to get the that information from the post data as easily as this. And that's also the JSON include that we have. So on the form that you saw, we can specify the conference name. It just grabs that name from here. We pass along the error next, which is part of the Node Express way of dealing with errors. And again, that's everywhere. That's not different. The different things are, what are we calling in terms of our green box implementation? What information are we showing? Blue box implementation, or command. So what are we changing? So we're setting conference name. That is our command handler. What is the command? This is the command, which is just populated with the name that we want for the conference. And then what happens if we fail? And then what happens if we succeed? If we succeed, we simply redirect to the name confirmation. That's kind of how we handle this. I really want to build something a little bit more structured than this, but right now we're playing in the world of Node Express for this, but we could definitely abstract this. The event modeling has a very standard way of progressing from step to step. We could definitely have something more generic in terms of, or not generic, but I would say a better convention that in Node Express implementation would have some even easier delegation to something else to do this. So that's all we need. And of course, the real magic is the command handler itself. And here we have this map reduce. One of the things, actually, I didn't do everything that I wanted here because we have a filtration on this, and we would rather have just the reducer. So so we can reformat this function to say, let's just use cursor AI here to edit, and we can say don't use filter, add a case, switch case statement inside the reduce. Let's see if cursor AI is good enough to know that, because yeah, that's kind of what we want. So we always want this pattern for everything we do in this application. Event sourcing is just map reduce over and over again. We don't want to, even though it looks shorter and it's nicer, this filter thing, we don't want that. We just want history.reduce everywhere. Right? We can make this, I mean, this is pretty dumb code, so I don't want it to have too much real estate. Of course, we're going to return the accumulator by default. And of course, our accumulator ends up being the last thing. So the last conference name. Remember, we can only have one conference at a time. So every time we start a new conference, this reducer is incredibly simple. All we do every time we hit a conference named event is return the event name. So at the end, our accumulator will have the last name that we specified, and that's all. So this dumb logic, I really like to not have a lot of real estate dedicated to it. We can also have a blank here as a default. I don't like nulls. Our only business logic here is if we didn't, if in our command we specified what the current name is, that we specified that in our drawing, our diagram. And we gotta go. So I gotta go in the next 2 minutes here. Let's see how far we can get, and I'll come back later for the rest of the explanation. But hopefully this shows you how everything is a map reduce here if you keep going through this. And now the testing is another thing. This is let's get through one more thing. So our testing that we run through here, there's no test function because we do the same kind of asserts, the same kind of setups every single time. So there's no custom code for unit testing. We just have a checkpoint where we describe what we're checking at that point in time. So when we have this name done, we have an event that's emitted that is basically this name. We can rename things. So we look at our history, which is the previous checkpoints. Currently, that's just one event. And then when we do this, that's a separate timeline. So here's an example of a previous event. And then we have an expected event when we do this command. And so names should be changeable. That's all we have. And then renames can be done multiple times. And then of course we have this renames not allowed if the name is the same. So this is the exception that we expect. And I've taken a bit of convention from Java or some other languages where we put the expected exceptions right above the function that's going to throw them. I like this convention. It's all the same functionality is in the same area here. But notice there is no code. So our test runner is the last thing I want to show you before I go. And the test runner is really just looking at those JSON collections that we just looked at here. And it's going for each slice that we have, the slice name, which is basically, what we were looking at just now is up here, one of the first tests. So set conference name, test, the conference name is set to a new name. The renames are allowed as we showed, and then this renames should be allowed multiple times. We see all of that here. Just going to move this a little bit wider so we can see more here. Why do we have that here? Yeah, I see this scrolled all the way up. That's still running. So yeah, if they pass, that's it. But essentially, it's these collections of these object collections that we have in here, and we're doing a for each, and then we're doing a reduce as we go through each checkpoint. Why are we doing a reduce? It's because we're collecting the previous events in each of these timelines that we have. This one has 3 steps. Some have even more. Those are the setup events here, and when we look at the accumulator, the events start empty. As we go through more and more slices, more checkpoints, we gather those up. You can see that is done here. So if a checkpoint has an event, we add it to the history that we're going to use for the next thing here. And so if at a checkpoint we have an event, we have a command, but we don't have an exception, we're just going to run the test function, which we have defined at the top in our JSON, and we pass on so far all the events that we have in this timeline and the command we want to execute, and we gather the result, and then all we do is stringify these. This is going to ensure that we do a property by property match, and that's it. That's the only assert that we have. We do something different when we're expecting an exception. So we should throw a specific exception. We assert that we did. We also check the message is the same that we want. So that's how we check for expected exceptions. And of course, for state stuff, we do the same thing. Instead of the result is the state, and we also do section by section. So hopefully this kind of explains how things work. Here's our summary. And then, of course, if we were going to run tests, we do that. Otherwise, we run the application. And those URLs, when we run the application, we simply look at the router and see which endpoints we handle, and we give a nice, easy link for each one, so that when we're testing the application, we can just click in the terminal and jump to that particular place. Very useful when you're using these fake events here too, to do a specific type of scenario. If you're working up, if you're working on the registration slice, you want to just automatically have these in your history, these fake events, so you can test that piece and then click on the URL for that registration piece and work on it. So these are all nice helpers. And then we have some command line tooling to dump these in whenever you like. And I can go through that this evening on the next stream. So thanks for your patience. Hopefully this was informative, and we'll see you next time. So until